Welcome to yet another episode of KickStart series by StudyMedic. I'm Dr. Sapna and I'm one of the mentors at StudyMedic. And today we are going to discuss pedigree chart analysis. Now this is a very interesting and a very important topic, not only for your Part 1 exam, but also for our daily practice. So let's move on. The quote for today is to help you to believe in yourself and to keep working on yourself one step at a time. As they say, consistency is the key to cracking any exam. But don't think that being consistent means never falling off track. That is part of being human. Consistency means staying on track, but more importantly, getting back on track immediately after you intentionally or unintentionally fall off. Just keep working on yourself one little step at a time, and over a period of time, you will become a lot better. As genetics becomes a more integral part of routine medical practice, it is essential that we, as obstetricians and gynecologists, are aware of advances in the understanding of genetic diseases and the fundamental principles of genetic screening and molecular testing. For your exams, few of the basic chapters like cell division, cell cycle, and chromosome structure are important, and knowledge about the various chromosomal abnormalities and genetic conditions is also tested. In today's session, we will try to cover basics of inheritance patterns and learn how to solve pedigree charts. Pedigree charts, as we all know, are diagrams that show the presence or absence of a trait in a family over several generations. It is a widely used method to track genetic diseases. Before moving on to tips and tricks of analyzing and answering pedigree charts, having a clarity on few of the basic concepts is very important for better understanding. To begin with, we must know about the various symbols used in making a pedigree chart. It is important to understand alleles and difference between dominant and recessive conditions, a diseased, healthy and carrier state, how they are represented in a pedigree chart, and the role of homozygous and heterozygous alleles. Knowing about Punnett squares is very helpful in the exam, as a quick scribble will help you to reach answers without having to memorize percentages at all. It is one of the easiest ways to calculate mathematical probability of inheriting a specific trait. It is a simple graphical way of discovering the potential combinations of genotypes that can occur in children, given the genotype of their parents. Here, for example, I have used a Punnett square to find out chances of having male or female progenies in a couple. Moving on to our topic for today, which is analyzing a pedigree chart and determining the mode of inheritance. A few tips or tricks, as you may call them, will help you to determine the answer in all cases once you have your basic concepts cleared. The most important thing to understand is that all conditions will be either autosomally inherited or through the sex chromosomes. It is also important to understand that the Y chromosome in the father will go to only the son. The Y chromosome is not transmitted to the daughter. Similarly, the son will get one X chromosome from the mother. Also, the daughter will get X chromosome from the father and one from the mother. As we move on, you will understand why knowing this is very important. So let's solve this algorithm. We are going to ask 4 sets of questions which are going to lead us to our final answer. Our first question will be, are only males affected, or are all sons of an affected father affected? In case the answer to both of this is yes, then we are dealing with a Y-linked condition. Suppose the answer to both of these is no, there are females affected in the pedigree chart that is given and all sons are not affected. Then the next question that we ask is, are there any cases where an affected child does not have an affected parent? Here it is important to understand that a dominant allele will manifest itself even in a heterozygous condition. Therefore, if an affected child is not having an affected parent, that will mean either the parent is not carrying the condition of the disease or is a carrier for that condition. So the answer to this is yes, we are dealing with a recessive condition. Our next consideration will be whether this is a sex-linked condition or whether this is autosomally inherited. So our next question will be, are all sons of an affected mother affected? Are more males affected? If the answer to this is yes, then we are dealing with an X-linked recessive trait. However, if there are males and females affected, then the answer will be autosomal recessive. Coming back to our second question, in case all affected children have one or the other parent affected, here we are now dealing with a dominant trait. And again, we need to make out whether it is an X-linked or whether it is an autosomally inherited condition. So our question will be, are all daughters of an affected father affected? Now we get back to the basic concept that all daughters will inherit the X from the father. So in case it is an X-linked dominant condition, all the daughters of an affected father will be affected. And in case this is not the condition, it is both males and females who are affected, we are dealing with an autosomal dominant condition. Now let us put these tips and tricks to some practical pedigrees, and then we will understand the concepts a little better. So let's solve a few charts using these tips. The first question, and it is very important to remember that we go in order and not jump to conclusions simply by looking at the chart. So males, as we know, carry an X and a Y gene, where Y is always inherited from the father and always passed on to the sons. As females don't carry Y, it is clear that Y-linked conditions won't affect them. However, nature can be tricky, and there is a condition called XX male syndrome or de la Chapelle syndrome, which you should read about after this video. Getting back to our question, answer to both these questions is yes. So this is a pedigree for a Y-linked disorder. Now let us know more about Y-linked traits. The most important thing that we've already discussed is that the Y chromosome is passed from father to son. So affected men will pass this trait to all the sons. This is also called a straight inheritance, father to son who will pass on to his sons and so on. This trait does not skip generations and daughters are not affected. So let's solve this chart. Only males are affected and all sons of an affected father are affected. So this is clearly a Y-linked inherited condition. Now moving on. In our next question, what do we see? So females are also shaded. Now for exam purpose, they may not show carrier states as a half shaded box or a circle or a box or a circle with a dot, but an unshaded square or a circle only may be given. But there is nothing to worry about, just follow the algorithm. So what do we have here? Are there any cases where an affected child does not have an affected parent? Yes. Next question. So as we know, a dominant condition does not have a carrier state even in a heterozygous condition, because dominant conditions will manifest themselves even in a heterozygous state. So as we have an affected child with unaffected parents who may be carriers, this is a recessive trait. So our next question is to determine whether this is sex-linked or autosomal. In this pedigree, we see at a glance that there are more males affected, but more importantly, all sons of an affected mother are affected. As we know, sons will inherit their X chromosome from their mothers. So this is an X-linked recessive pedigree. Now let us know something more about X-linked recessive traits. These are more in males than in females, and it may skip generations. Here we may have three kinds of conditions. In first, the father is affected. In the second condition, the mother is a carrier. And in the third situation, the mother is affected. Now, By making a Punnett square, we can easily find out whether the child will be affected or not, and this might be asked in the exam as well. So they might ask you that if the father is affected or if the mother is a carrier, then what is the percentage of offsprings that might be either affected or carrier or normal. So here we've drawn a Punnett square. If the father is affected, we can see that no male-to-male transmission occurs in these conditions and all daughters have become carriers because the only X that was there in the father has now come to the daughters. If the mother is a carrier, then there is 25% chance that she will have a son who is affected, 25% chance that she has a daughter who is a carrier, and 25% chance that she might have a son who is normal, 25% chance she might have a normal daughter. They can ask you in different ways. So what is the percentage of daughters who is a carrier? 50% of the daughters will become carriers. How many percentage of offsprings are normal? 50% chance that the offsprings are normal. So on and so forth. If the mother is affected, that means she's carrying both the recessive alleles on both her X's, then all the sons will be affected and all the daughters are carriers. So there is 100% chance that the children will become either carrier or affected. 100% chance that all the sons are affected and all the daughters will become carriers. Now let us have a look at this pedigree. And what do we have here? This affected child does not have affected parents, so we are looking at a recessive condition. All the sons of an affected mother are affected. This condition in this pedigree, we can see that more males are affected than females and male to male transmission is not occurring. So this we are looking at what is an X-linked recessive trait. So now this is our pedigree chart. And what do we see here? Let's begin with our algorithm. Our first question is negative. We do have an affected child with unaffected parents. Like we said earlier, these may be carriers, so this is a recessive trait. The difference here is that all sons of an affected mother are not affected. So this does not look like a gender predisposed condition. Also, males are more or less equally affected. So we conclude that this is an autosomal recessive pedigree. Let us know more about autosomal recessive inheritance. Affected children are born to affected or carrier parents. Both males and females are equally affected. This trait can skip generations and it is more likely to appear in consanguineous marriages. So this is a pedigree chart. Now what do we see there? Affected children are born to unaffected or carrier parents. Both males and females are affected in equal frequency and the trait has skipped a generation. So this is an autosomal recessive condition. Now let us have a look at another pedigree chart. And what do we see here? So it is clear that the first question is a negative. Now we need to know whether there are any cases where an affected child does not have an affected parent. So as we can see here, all the affected children have an affected parent. So we are not dealing with a recessive condition and we can move towards a dominant condition. So now we ask whether all daughters of an affected father are affected. So yes, all the daughters of an affected father are affected, and as we know, the daughters get their X chromosome from their father. So here we are dealing with an X-linked dominant trait. Now let's have a look at this pedigree. All the daughters of an affected father are affected. All affected children have an affected parent and all generations are affected. There is no skipping. Hence, we are dealing here with an X-linked dominant inheritance. And finally, we have the fourth inheritance pattern. But we don't jump to the answers. We will go through all the questions systematically. So here again, only males are not affected. We can see both females and males being affected. So we are looking at our next question. Are there any cases where an affected child does not have an affected parent? No. So we are not going into the recessive traits. We are now dealing with a dominant one. Also we see here that all the daughters of an affected father are not affected. This is a daughter, father is affected, but she is not having the disease. So this is not a gender predisposed condition like an X-linked dominant one. This is an autosomal dominant pedigree. Autosomal dominant inheritance. Affected children are born to affected parents. Both males and females are affected in equal frequency, and the trait does not skip generations. Now let us have a look at this pedigree chart. Affected children are born to affected parents. Generations are not skipped. Males and females are affected with similar incidence. So this is an autosomal dominant inheritance. Now let us solve this pedigree chart. Our questions will remain the same. Are only males affected? No. Are all the sons of an affected father affected? No. Are there any cases where an affected child does not have an affected parent? No. So we are going towards a dominant trait. Our next question, are all daughters of an affected father affected? Also no. So is this an autosomal dominant inheritance? Well, also no, because there is skipping of generation here. So now this is what we call mitochondrial inheritance. Mitochondrial inheritance is exclusively maternal, as none of the mitochondria from sperm survives fertilization. Therefore, only daughters of an affected mother can transmit the trait related to the mitochondrial DNA. So here, an affected mother will transmit the condition to all her children, while an affected father does not pass the condition to any child. This is also called as maternal inheritance pattern, and unlike the nuclear genes, mitochondrial genes are only inherited from the mother. It is also called as extrachromosomal transmission. Look at this pedigree chart. Again, the affected mother is passing the condition to all the children, and an affected father is not passing the condition to any of the child. So this is a mitochondrial inheritance pattern or a maternal inheritance pattern. Now we'll be going through a few questions and analyzing the pedigree charts and the questions linked to them. So moving on to the questions. A disease shows its transmission from an unaffected carrier female to some of the male progenies. Find the nature of this trait. So now the options will be autosomal dominant, recessive, X-linked dominant or X-linked recessive. So let's take this one by one. Could it be autosomal dominant? Now we know that autosomal dominant conditions are passed down through the autosomes. So it is not a gender-linked condition. So there is no condition in which a carrier female will pass it to a male progeny or something like that. Also, since it is a dominant condition, it does not have any carrier state. Even a heterozygous allele will have an affected person. Could it be autosomal recessive? Again, this is passed down through autosomes. It is not a gender-linked disorder. Could it be X-linked dominant? Now, X-linked dominant, as we know, are passed down through the X chromosome. So they are gender predisposed. However, in a dominant condition, there are no carrier states. So this is not an X-linked dominant condition. And here we are dealing with an X-linked recessive. So now we need to know which of these pedigree charts belongs to an X-linked recessive condition. Now our next task is to find out which of these pedigrees is an X-linked recessive trait. So that will be our final answer. Given here, we are going to look for pedigrees in which an affected child does not have an affected parent, since we already know that in dominant traits, all the affected children have affected parents, and in a recessive trait, an affected child does not necessarily have affected parents. So, in amongst the given pedigrees, we have pedigree A, which shows that affected children do not have affected parents, and also in pedigree C. Between pedigree A and pedigree C, we know that in pedigree C, both male and female are involved, and in X-linked recessive conditions, males are more involved than females. So, pedigree A is our final answer. Now, let us try and solve this pedigree chart. As we can see here, that both males and females are involved. So, this is not only males, and this is also not mitochondrial, because an affected father is transmitting the trait. So all affected children have at least one parent who is affected. So this is between answer A and answer D, which are both showing dominant conditions. So which one would it be? Now an affected father is passing it on to his son. Now we know if it were an X-linked condition, affected fathers do not pass it to the son. So our answer is this is an autosomal dominant condition. I hope you're now catching up with all the tricks. Let's do one more. What mode of inheritance best explains the pedigree shown below? Now what we can see here is that all the affected children have one or the other parent who is affected. So here we are dealing with a dominant condition. Now our answer could be between option A, option C, and also option E. Now let us see which one is it not. Why is it not autosomal dominant? Because we can see that generations are being skipped. Alright, so between X-linked dominant and mitochondrial. Now let us think. In an X-linked dominant condition, all the daughters of an affected father will be affected. But here we see that fathers are not affecting their daughters. So this is not an X-linked dominant condition. It is a mitochondrial condition. Great. So now we are understanding it better, right? Now let's solve this one. Here we have only males affected, but not all males are affected. And this is why in the beginning we had said we will not jump to the answer but go in the sequence of the algorithm. So what are we looking at here? Now the next step was, any of the affected child has an unaffected parent? Yes. So what do we have here? A recessive trait. Now it is between B, autosomal recessive, and C, X-linked recessive. Now what could it be? As we see, there are more males who are affected here. So this suggests that this is an X-linked recessive condition. Now let us solve one more. What mode of inheritance best explains the pedigree shown below? This is definitely not Y-linked. Does any affected child have an unaffected parent? Yes. So we do have an answer here. It is a recessive trait. Now our options are limited to B and C, autosomal or X-linked recessive. So what is it this time? Are all sons of an affected mother affected? Yes. Also, there is a slight predominance of male affliction. So this is clearly an X-linked recessive condition. Now please do not confuse between the affected father passing the trait to his sons, as his partner is also affected. So the sons are inheriting the recessive trait linked to the X chromosome from her. This is confusing, but it is definitely interesting. Now let's attempt another question, but with a slight twist. The pedigree below is of a family with achondroplasia. The family with the red arrow are planning to have another child. What is the probability that the child will inherit the affected allele? Now, for this, we first need to know what kind of inheritance does achondroplasia have. So, achondroplasia follows an autosomal dominant inheritance. Next, we put a Punnett square to reach our answer. In the family marked, the female is unaffected, so she is carrying two recessive alleles for the trait, Now let us say they are AA, small letter A and A. The father could be both heterozygous or homozygous. Now, since not all of the offsprings are affected, which would have been the case if the father was homozygous, we know that the father marked here is heterozygous. And in the Punnett square shows that there is 50% probability that this couple can have an affected child. And that is our answer here. In summary, this is the difference between all the conditions that follow the Mendelian pattern. These are the conditions that are more importantly asked in our exams. We must know their inheritance patterns because the questions can be based around them. So that's all for today. Thank you everyone for your attention and time. We hope this presentation makes solving pedigree questions in the exam a lot easier for you. If you have any questions or doubts, do send them in the comment section and we will get back to you. We look forward to hearing from you, so do drop in your feedback, which will help us in improving ourselves. Keep tuned on to the Study Medic channel for more such helpful videos. Keep studying and all the best for your exams.